Hey there, Factorians. First thing I just want to say is thanks. This video has over 120,000 views on it as of last I checked, and that's amazing. That's awesome. I'm so glad that so many people were interested in this, and I wanted to make a follow-up here to sort of address some of the things that I saw in the comments, help out with a couple of technical issues, and also just sort of give my thoughts on a couple of the sort of future research angles that people had. So given that there's going to be a bunch of stuff in this video, and this video is going to be a much lower production quality video, I'm just sort of shooting this with OBS. Here we go. I've got chapters, so you can figure out which parts you want to watch if you don't want to watch all of it. But I hope you stick around for the end at least. Yeah, let's get started. All right, so first thing I want to address is all the issues that people had running the scenario. This took me a little bit of time to figure out, and for about 2 weeks after the video went up, I was actually out of town and wasn't able to touch this at all, which was very frustrating. But I'm back now, and I took a look, and I was able to figure out the problem pretty quickly. So basically, I had told people to install the recursive blueprints and the Moon Logic Combinator mods. Those are both very important. There was also one mod that was technically required, and I didn't realize it, the Logistic Train Network mod. You might say, that's crazy. There's no trains in here. So I had been using a particular circuit signal for this particular circuit, and this comes from the Logistic Trains Networks mod, and I had totally forgotten that. I've switched it in the newest version that I've uploaded, which is completely fixed and should work perfectly. I've switched it over to using the pink signal. The purpose of this combinator, it's from like a while ago. Basically the idea here was I didn't want anything from the mall, I didn't want anything from the mall to be putting demand on the network if we were out of water. Because when you run out of water, that's when you start having issues with nuclear, because nuclear requires water, and then you start having power crises and all kinds of stuff. In practice, this might not really be needed. It's sort of just a thing I thought might help, although in practice I think usually the water crises end up sorting themselves out. But either way, I've patched it. I've got the pink tile signal here instead, and so that should all work just fine. One other mod that I would definitely recommend installing is the auto research mod, and the reason for that is that it's a mod that is so basic that I forget that it's not even like part of vanilla Factorio, and I'm sure that like in Factorio 2.0 it'll probably be in there, because it's just like once you get into the late game, this feels like such a natural thing. Basically the idea is, let's start playing. Basically, the mod will automatically queue up research, and this is really important when you are running for hours and hours at a time because you need that research to keep coming in. So yeah, getting something to do that automatically is really nice. If you press Shift T, you can see the screen for the auto research mod. I don't use a lot of its more complicated functionality. I barely even do anything with these buttons. You can probably do some really smart stuff with this, but I've had some difficulty getting it to work. But its main purpose of actually just like getting research to stay on the queue, it does that job. And so I definitely recommend installing that. Aside from that, this new version should work fine. Please let me know in the comments if there are any issues further. Just make sure, again, that you've installed those mods: Recursive Blueprints, Moon Logic, and Auto Research. And in fact, I will quit the game here, and I'll show you those in my, I'll show you what mods I have installed. So this is all of the mods that I have installed at this moment. In the event that anything else goes awry, if you want to get the exact setup of mods that I have right now, this is them. Some of these were used for the train-based stuff. Some of them are things I just installed on a lark and then never really used again. But just wanted to have that all documented in case anyone was interested. All right. So I received a lot of comments that people were having difficulty installing the scenario. I'm not sure that I'll be able to help each individual person, but I want to make sure that it's sort of clear like exactly how you take a scenario that someone gives you and install it in Factorio, especially given this is kind of an advanced workflow. So let's go over this real quick. So let's say you've downloaded the file. It's a zip file, and it's got this name. We're going to open this zip file, and inside there's a folder. All right. Inside this folder is this stuff. It should look exactly like this. Now I'm going to go back up. So I'm inside the zip file still. I'm looking at the folder. There it is. Now over here, I'm going to go to a special folder. I'm going to go to %appdata %. It's got to be all caps, % on either side, nothing else. And when you hit enter, this will magically expand to be, your drive, users, your username, app data, roaming. And in here, there should be a folder called Factorio. And in there, a folder called Scenarios. And you should copy this folder here over to here. Make sure it doesn't end up inside of one of those other folders. And you can do this while Factorio is running, but I would recommend doing it like while you're on the main screen like this. And now, as you can see, this is the one that has the date stamp, 2/19/2024. If I go to single player, new game, there it is right there. So you can do this while Factorio is running, although maybe don't do it while you're on this exact screen. On this note, I would also say that scenarios are special in that they are not synced between computers. If you have Factorio installed through Steam on multiple computers, your saves will sync between those computers, but your scenarios will not. That's important to know. Saves are a little bit different. If you're installing one of the save files, note that these actually are zips, and you should just take that zip file and put it right in here inside of roaming Factorio saves. Ignore that. And then they will show up. And the cool thing about installing through a save file is that Factorio gives you the option to when you first open the save file, it goes, hey, these mods are missing, or these mods aren't installed at the same version numbers. Do you want to sync your mods with the mods in this save file? And that's really nice. So that can be an easier way to get started. So that's basically a couple other things I guess I'll note about scenarios is that if I go into one, so this is the one that I've just posted, I can edit one of these Lua files. I use Visual Studio Code for this. And I can do it even while Factorio is running. I would be careful about this though. If you edit this while the scenario is running, I'm not sure if or when you would see the results of the change. I would say only edit this if you're like on the Factorio main menu or something else. Definitely don't edit these files if you're in the map editor or if you're running the scenario. Weird stuff can happen. And definitely be careful with like what you do in here. I use this particular function and not like the on-player created function for a reason. So, you'd want to get acquainted with like what all of these mean. And there's good documentation on Factorio's website about that. So that's all I've got for now, I think, on a sort of tutorial around how scenarios work. Now let's move into the next bit. So I want to take a chapter here to address sort of like some of the discussion in the comments around like how I built the algorithm or why I made certain decisions, and sort of like my philosophy around this, I guess. Because a lot of people were suggesting things that I think are great ideas. And by the way, like if you want to do some of those ideas, go ahead. You can start from this if you want, or start fresh, or use this as an example, or whatever. All of this is open source. Take it, do whatever you want. I wanted to talk, I guess, a bit about like why I didn't do certain things. So my idea here is that like when it comes to making a Factorio megabase that does 1 rocket per minute or 1,000 signs per minute consumption, which is what I was going for, one way to do this, there's sort of in writing, they say there's planners and pantsers. Planners are people who like plan everything out ahead of time, and pantsers are people who just sort of write by the seat of their pants and make their characters do whatever. And there's positives and negatives to both. I wanted to go with a seat of the pants kind of way of doing this, where the AI had to figure out what to do at each step on its own. With the idea there sort of being like maybe the AI would come up with a new way of designing a factory that I wouldn't have come up with if I had given it all the instructions up front. I don't know that that actually happened, but it's an interesting idea. It's sort of like the way that we think about a lot of AI neural network stuff is we go into it giving the computer as little instruction as possible and trying to make it come up with as much as possible. Now, as I'll get into later, there's reasons why I didn't go for an actual AI, like neural network kind of approach. But I did want to kind of capture that spirit a little bit. And I feel like I did a good job of that. If you disagree, again, feel free to take this and try and take it in a different direction. To give an example of what like a more planning-based thing would be, here's a video by someone, I believe the channel is called Advanced Topics with Griswold. This guy has something awesome here. So I'm going to link this in the description. You should check out this video if you're interested in this topic. I'm not going to like play the whole video here. I just want to show like a couple things. Basically, what he does in this video is he has designed a factory. He basically went into the Factorio online calculator, put in like 1,000 white science per minute, and then just like was like, okay, this is how many factories of each type I will need to achieve that throughput. And then divided it up into these tiles, as you can see here. Some of the tiles probably make intermediate things along the way towards making, green circuits or whatever. But this thing, and again, I'm not going to play any more of this because I want you to watch this. This is a great video. This is a chef's kiss, just immaculately designed, clockwork little thing, and like. It does its job. It's like very clean. It's like probably nothing's wasted. It's glorious. And the thing is, when I started work on this, I mean, stuff like this already existed. People were already doing this, and this is like a different kind of thing. I think like this is very much the planning side. If you wanted to, yeah, you can go into the Factorio calculator and with pencil and paper or whatever, design just the perfect factory. And I wanted to take a different approach. So again, that's why I went with sort of something where I have the factory sort of design itself, or that was sort of my goal. I wanted to get as close to that as possible. In the end, I did have to sort of hard code some things. Like I did have these tiers where, these are the things that require no previous stuff except for or. These are the things that require the tier 1 things. These are the things that require the tier 2 things, et cetera. I did have to, encode a bit of stuff into the algorithm, which I think is a little bit unfortunate. But for the most part, as long as the algorithm knows about this general structure that you can't make these things without these things, it's able to just sort of just like go on its own and like do a lot of design work in a sense, just by sort of reacting to what the factory needs at any moment. So that's why if I seem a bit like. And I know I'm probably not doing a super great job of explaining this. I know it's a bit of a hand-wavy, intuitive kind of thing. But I guess that's sort of what I would say, is that there are some ideas that people proposed that I think are great, and they should go and do them. But for me personally, this is what I wanted to do. And I feel like I've done a pretty good job of it. And if you want to take it further, I'd love to see what you're able to do. So that's what I have to say on that matter. All right, so... One topic that I saw in a lot of comments was, okay, this is cool, but can we apply like some real AI to this? And by real AI, people mean, algorithms like, genetic algorithms, hill climbing, Monte Carlo based stuff, AlphaGo kind of stuff, reinforcement learning, and so on. And those are all really interesting things that I think if someone can make it work, I'd be very interested in seeing how it turned out. What I would say about AI is that there are certain situations where AI stands to improve a lot on existing techniques, and certain areas where existing techniques are pretty good and AI is going to have a harder time doing a better job. So there's no real good hard and fast rules for this, but in general, the way I think about it is that if you have a deterministic algorithm that has that does the correct thing almost all the time, replacing it with AI, it's going to take an AI a lot of training and a lot of layers in order for it to. First, what it would probably end up doing is approximating this function. It would, through all those layers, it would find a way to basically do all of this logic, and the hope would be, I think, with more training, a neural network would then get to a point where it discovered a function that was better than this, more efficient, possibly more compact. And that's like totally possible. I don't like, I would not rule that out. AI has definitely done stuff like that for many kinds of problems before. But in my experience as somebody, like I've been following AI, literature for a while, and like looking into its use in practical, applications. And to draw a comparison with something like AlphaGo. AlphaGo is based on a technique called reinforcement learning. You'll see the word Monte Carlo tree search come up a lot. That basically means that it has a network that tells it, hey, this is what the best possible move is, and the second best, and the third best, and the fourth best, and it ranks them. And then the Monte Carlo tree search will sort of basically like not always pick the best one, because the idea there is that if you always pick the best move, then you can find yourself in what's called a local maximum, where you stop getting better, and there's a better maximum, but in order to get to that better maximum, you have to get a little bit worse before you can get a lot better. So these sort of Monte Carlo-based methods are really cool for reasons like this, and they get combined with all kinds of things like reinforcement learning and whatnot. I'm being very hand-wavy here because I'm trying to keep this at a lowish level, but basically one thing that AlphaGo has on its side when it's trying to play the game of Go is that the game that it's playing can be created in a way that doesn't use a lot of computation power. You can make a Go game that runs like in the command line and has like no interface and uses barely any compute power. And this is really important because the actual training that you do, like running the network and having it try and find out what the best move is, then like afterwards taking all the results of the games and back propagating them and retraining the algorithm, that all takes a lot of compute. And the only way for it to make any sense at all is if the actual game itself takes barely any compute. And with AlphaGo, this is a perfect situation where you've got, DeepMind, owned by Google, who have, just oceans of graphics cards chewing away at the training, and like, probably a fistful of CPUs actually running the game. And with that fistful of CPUs, they can run millions of games, very quickly. I don't know exactly how fast, but it's very fast. Now, on the contrary, Factorio, to run an entire Factorio run, so to speak, first of all, Factorio runs are open-ended, but like in order to really get a sense of like, is it doing a good job, you'd probably want to have it run for like at least 24 hours of in-game time. Now, as we can see with, when I run Factorio on my computer, I can get it up to about maybe 10 times real-time speed when I'm at the beginning of the game. And then towards the middle and end of the game, we get back down to like real-time speed. So a 24-hour run, I mean, that could take like, if you do the calculus on it, probably like 12 hours. And that's for one run, and that uses the full computer, my full computer. So to get like 1,000 runs or 1,000,000 runs would take like days, months, years, or a giant ocean of servers. And that's why I feel like a lot of AI techniques that would be based on, doing thousands and thousands of runs are gonna run up against this blocker that we don't have a way to simulate Factorio while using like low compute. Even if you ran Factorio headless, I don't think you would get that much more compute capability, just because like Factorio, if you've been reading those Friday facts that the dev team puts out, I mean, and you've been seeing like the crazy stuff that they put into enemy pathfinding, pollution propagation, like random generation of whatever, like they are tightening down everything. Factorio is an absolute gem of efficiency, and yet it still requires that much compute in order to simulate a world this large. So I don't know, I think, if you want to take a crack at this, go for it, totally. Like, I don't mean to tell anyone, like, no, you shouldn't even try, because you absolutely should give it a try. Just don't spend too much money. To give an instance, though, of someone else who's done something that I think is really cool. So I'm going to link this in the comments. This is an excellent video. You should absolutely go watch it. basically, in this video, this guy, Peter Whitten, he built a reinforcement learning, so kind of like AlphaGo a little bit, a reinforcement learning based AI that would play Pokemon Red. Now, contrary to Factorio, Pokemon Red is a much, like, you can run this game at probably 100 times speed on a modern CPU. And he does, and he takes advantage of that, heavy advantage of that. As you can see here, he's running hundreds of these games. Look at it, it's tons and tons and tons of them. And he actually, towards the end, he talks about how he, and again, you should absolutely check out this video. Towards the end, he talks about how he had to get server farms. I think he used DigitalOcean or something like that, and just to run the games. And that, I believe he said that this video cost him $1,000 to do. And that's for a game that is way less complicated and way less compute intensive than Factorio, while still having a fair amount of space, search space within it, I guess. So definitely check out this video, because if you want to try and do this with Factorio, you first have to do it for a game like this, I think. Start small and build up towards a modern game like Factorio that actually uses our actual compute. But yeah, I would love to see more things like this. I think this is a wonderful thing, and if you have the ability to do it, you should, if for nothing else, so I can watch it. This is definitely something I've thought about doing with certain games. I've mentioned before on my other video how I'm really interested in tool-assisted speedruns. But tool-assisted speedruns are more like what I'm doing, where I'm sort of well, actually, no, tool-assisted speedruns would be if I told the factory exactly what to build. I mean, this is something new, something wonderful. I'm glad that he got 5.6 million views on this. This is a wonderful, incredible video. So yeah, that's sort of my thoughts on this, is that I think AI would be really interesting, but given that the AI would be up against a pretty good algorithm that it would have to improve upon, and also that it would require just tons and tons of compute in order for you to actually get it to work. I don't know that how likely it is. And that goes for reinforcement learning, but really anything that involves running 1,000 Factorio games. So genetic algorithms, maybe hill climbing. I'm not as familiar with hill climbing, so maybe not. But yeah, so I hope that's not too much of a downer, but I hope that if you're interested in this idea of AIs playing games, starting with a simpler game like this is definitely a great way to go. All right, so last thing I want to say is just thank you. In my entire life, I'm pretty sure I've never had anything that I've done get seen by 100,000 people or 100,000 times or whatever the number is. That just feels awesome. And I know that these are small numbers, these are chump change by YouTube standards, but for someone who doesn't usually do YouTube that much, it is pretty affecting, and just it feels great to know that so many people were interested in this topic. So thank you. And as I said before, I don't expect this to become a Factorio-based channel, but if you look around at some of the other videos that I have on my channel, there are things recordings of technical talks that I've done, demos of things that usually involve tech and theater, because that's a lot of what I do. And so, if you're interested in that kind of stuff, definitely stay tuned and subscribe. I also, while I don't know that I'm going to keep going with Factorio automation, I haven't ruled out the idea of someday doing a task of something, a tool-assisted speedrun. I can't say that'll happen anytime soon, but if it ever does happen, it'll be on this channel. So, I guess stay subscribed for that if you're interested. But yeah, until next time, happy hacking and stay building.